Bismillahirrahmanirrahim. Today I'd like to talk about how we find midpoints and distances in a Cartesian plane, or a coordinate plane if you like. So we're given here 3 points, point A, point B, and point C, and we're given the ordered pair that belongs to each. So the first job here is for us to, let's say, graph it. So we're going to graph these 3 points in this Cartesian plane. Well, it's mustahab, it's good mathematical manners, if you like, first to label the axes. So of course this is the x-axis here, and this would be the y-axis here. And it's also mathematical good manners, or mustahab, so to speak, to label some of these points over here so we know what each increment means. So let's call this one 1 and 2, and this would be 3, and this is -1 here, and this is -2 here. Those would be the points, and here we can label these like 2, and that would be 4 like this. So, and then you can call this -2 like that. So you don't have to label every single one of them, but we have to give the reader an idea of what the increment is between each of these points. Okay, so we have labeled the graph before we even begin. Now you notice in this particular Cartesian plane there's arrow here and there's an arrow here, but there's no arrow here and there's no arrow here, but it is assumed that it's there. It's just not drawn to make it look a little bit more prettier, but there should technically be arrows at all ends because these are not rays, these are in fact lines. X and Y axes are lines that go in infinite directions on either side. Okay, so anyway, so we have labeled the axes. Now if you notice, of course, these are all positive numbers here, and on this side this is all negative numbers here. Where the two axes intersect, where the x and y axes intersect, would be right here, of course. That's the origin, right? That's called the origin, and has ordered pair 0, 0. So the origin is where the middle of the x-axis and middle of the y-axis, so to speak, they meet, and it's the ordered pair 0, 0. Okay, that was just a side detail. Now let's graph these points here in the plane. So point A is -2 and 1. So you go, the x value is -2, and the y value is 1 here. So this is point A. You can label that as point A, and if you wanted to, you can write the ordered pair -2 and 1 here over there. So you notice again that points are labeled with capital letters. Okay, that's point A. If you didn't want to write the ordered pair like this, and if you just wrote A over there, and that would be okay too. All right, but for now we will do it to be complete. And then let's graph point B over here. Point B is x is 2 and y is 1. That's right there. So that's point B, and the ordered pair belonging to B is 2, 1. And point C is ordered pair 2, 4. So it's 2 and 4 right there. That's point C, and that's 2, 4. So those are the 3 points. Now, if we were to connect these 3 points, I don't know why we would, because we're not given any instructions to do so. But if you were to do it, and you'll notice this in fact is a triangle, because any 3 points will actually, when you connect them, will give you a triangle. And this actually would be a right triangle because this is 2 and 2, and it goes straight up, right? But we're not told that. But if we were told that these 3 points represent the endpoints or vertices of a triangle, then we could connect them and there would be our triangle, right? So anyway, in this case, we're not told that these are this is a triangle, so we just leave it at that. So this is how you would graph points in an ordered points in a Cartesian plane. Now, let's say if we were asked to find the midpoint of this AB right here. So AB, this is a segment AB. Now, if we were told that we have a segment AB, then in fact you could connect these 2 points. So if let's say if we were asked to find the midpoint, of segment AB. Now we are given that we have a segment AB, so we can actually in fact draw the segment AB. So here it is. We can draw this like this. Okay, now if you wanted to find the midpoint, that's easy enough. Okay, so the midpoint, there's a formula for this. You can write this. So the midpoint formula. So midpoint formula is this. The midpoint is the average of the x's and the average of the y's. That's easy enough. Like I've drawn over here, I've drawn a number line over here, and I placed 2 points here on the number line, points A and B. Now, if I wanted to find the midpoint of this, I simply take the average of the two. That is, I take -4, and I take 8, and I divide by 2. -4 plus 8 is 4 last time I checked, and 4 divided by 2 is 2. So the midpoint for this particular, these two particular points would be 2 right over here. So that would be like the midpoint, right in the smack in the middle. In the same way, we can find the midpoints between any 2 points by taking the averages of the x coordinate and then taking the averages of the y coordinates, okay? Because that's what this formula means. x1 means the x coordinate of the first point, and x2 means the x coordinate of the second point. y1 and y2 are the y coordinate of the first point, and y2 is the y coordinate of the second point. So if you wanted to find the midpoint here for A and B, all we have to do is take the average of the x's and the average of the y. So if the midpoint here would be average of the x's, that's -2 plus +2. Those are the two x values, and you divide that by 2 to find the average. And you take the average of the y values. You take 1 and 1, 1 plus 1, and you divide that by 2, and this would be the ordered pair that belongs to the midpoint. So -2 plus 2 is 0. Last time I checked, 0 divided by 2 is 0. 1 plus 1 is 2. 2 divided by 2 is 1. So 0, 1 is the midpoint of the, let's call it the midpoint M. So 0, 1, x is 0, and the y value is 1 right there, and that is the midpoint here of this particular segment AB. So the midpoint is very easy to find. You simply just take the average of the x's and average of the y values. Now let's say if you find the midpoint of segment AC. So there's a midpoint. Let's call this M2, okay? Just for the sake of it. So the midpoint of segment AC. Okay? So let's draw this segment here now, because we told that we have a segment. Let's draw this. AC would be like this, and we're asked to find the midpoint of this. And again, that would be easy enough. We just take the average values over here like this. So we take the average of the x's, so -2 plus 2, that's this and this. You take the average of the x's, and you divide that by 2, and to find the y value, you take the average of the y values. That's 1, and that's 4. You take the average of that, and you divide that by 2. So you get 2 plus 2, 0, and this would be 0, and this is 5 divided by 2, or 2.5 if you like, or 5 divided by 2, 2.5. So the midpoint here would be 0 and 2.5, like there, okay? So that's the midpoint right here, okay? That's M2 right there. And you can label this on the graph too if you wanted to. That's 0 and 2.5, like that, okay? So finding a midpoint in a Cartesian plane is very easy, and that is the formula for finding the midpoint. Okay, so the last thing I want to talk about is finding distance between 2 points in a Cartesian plane. So here we're given 2 points, and we're asked to find the distance between these 2 points. Let's label these points, points A and point B here. So we're asked to find the distance between these 2 points. In other words, what's the length of this particular segment? And we didn't draw it, but we just asked to find the distance between these 2 points. To do this, we have to recollect the distance formula from algebra. So the distance formula is the following, okay, and that's like change in x square plus change in y square. So this little, it's not a triangle, it's like a capital letter delta, actually, from the Greek alphabet. So this symbol here represents change in, okay, So it stands for those words. So you read this as change in x squared and change in y squared. And if you were to write this out in the long version of the same formula, you would write this as follows. So here it is, a nice long radical symbol. So change in x would be x2 minus x1 x squared plus y2 minus y1 squared. And they take the square root of that to find the distance. But this, of course, is a much shorter version of the same, and it's much easier on the eyes and easier to remember. So that's how I typically write the distance formula. Specifically, the distance between 2 points is change in x squared plus the quantity change in y squared, like this. Okay, so but nevertheless, that's the distance formula. Of course, when we talk about x2 and x1, y2, y1, we mean any two ordered pair. The first ordered pair would be x1, y1, and the second ordered pair, let's say over here, would be x2, y2. So this x1, x2 business and y1, y2 business represents two different ordered pairs. So in order to find the distance between these 2 points, then we need the ordered pair that belongs to each one of these points. Okay, so A here, if you were to go by 1, 2, I didn't label any intervals here. It might be better to do so like this, 1, 2 like that, and -2 and -4 like this. So at least now we have our intervals labeled. So then I could write the points over here. So let me just do that. So A would be like -3 and up 2. So this is -3 and 2, and B looks like it's 2 and -1. So those are the ordered pair that belongs to these 2 points. So if we wanted to find a distance between these two, we would do the following. So change in x squared, doesn't matter which one you pick to be x1 and y1 and x2, y2, you could pick either way and it would still be alright, and as long as you're consistent, so keep yourself straight. So x2 minus x1, and doesn't matter which one is 1 and 2, so just subtract the 2. So it's -3 minus 2 squared. So I picked -3 and subtract that from that, and that I have to square that, and then plus the change in y, that's 2 and -1. So I write those. So 2, now minus, so you're subtracting, so this is minus right here, that minus over there, 2 minus, and then the -1 over here, 2 minus -1, like this. So this -1 being the y coordinate. So x minus x, -3 minus 2, and y minus y, 2 minus -1. So of course these two will go like this, and this will become as follows. -3 minus 2 is -5 squared, plus that's 3 squared, correct? So this would be like square root 5, -5 squared is 25, and 3 squared is 9. You add those two together, I believe that is 34. And you can't really simplify this. You could do this on a calculator. You punch this in a calculator, you'll get an irrational number. It's not a nice clean square root. When we say it's not a nice clean square root, what we mean is it's not a perfect square. If you remember, perfect squares are numbers like 4, 9, and 16, 25, because if you take these square root of these, square root of 4 is 2, square root of 9 is 3. Those are nice, neat numbers, right? 4, and this is 5, and the square root of the next perfect square is 36, and square root of that is 6. But now you observe, in fact, 34 is between these two perfect squares. In other words, 34 is between square root of 25 and the square root of 36, okay? So this is not a nice, neat square root. If you punch that in a calculator, it will come to be an irrational number, a decimal that goes on forever. But it's the reason I'm doing this particular exercise here is to show you to be able to think about this a little bit. So a square root of 34 is between these two perfect squares. That's 25 and 36. So it's between 5 and 6, because square root of 25 is 5, square root of 36 is 6. So square root of 34 is between these two numbers, and that's 5 and 6. It's closer to clearly 36 than it's to 5. So it's closer to 6 than to 5. So I'm going to guess it's going to be, the square root of 34 is going to be like 5.84 blah 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 blah. So that's my best guess. Now I'm going to actually punch that in the calculator and see what that comes up to be, okay? Now you're going to have to trust me on this. I actually did not cheat, and I just did that in the calculator, and this comes up to be 5.82 0.3095, blah 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 blah. It's pretty good, huh? It was not a bad guess, right? So that in fact is the distance. That's an irrational number. If you want to write it as a precise number, the distance between these 2 points is a square root of 34. So the distance is square root of 34, and that's the length of AB. If you were to draw an imaginary segment, AB, and the length of AB would be the square root of 34, and that's how you find the distance between 2 points in the Cartesian plane. This is the distance formula, and this, along with the midpoint formula, you must know. I was trying to find it right over here. Here we go. So distance formula is this the distance between 2 points in the Cartesian plane is square root of changing x squared plus changing y squared. Inshallah, we shall continue from this next time. Until then, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.